This is 7.1 part 2. In this part we will identify the percent rate of growth or decay given the exponential equation, and we will also model situations with exponential equations. So we're mostly going to write equations here. So this is the general form for our exponential equations. A of t equals a times 1 plus r to the t. Each of these different variables has a specific meaning. So a of t is the amount after some time. So this is our ending amount we have at the end. A is our initial amount. So this is the amount that we start with, whatever it is that we're growing or decaying. R is the rate of growth right here. And you put that rate in decimal form. So if we had a 5% rate of growth, we would write that as 0.05. T is the number of time periods, and the number of time periods have to be in the same form as the rate of growth. So if you have a 5% per year, then time would have to be in years. If you had 5% per month, then the time would be a number of months. If r is greater than 0, we're talking about a growth function, and if r is less than 0, it's a decay function. 1 plus r is also called the growth factor, or if it's 1 minus r in the case of a decay function, then it would be called the decay factor. So here's an example. Suppose we invest $1,000 into a savings account at the end of 6th grade. The account pays 5% annual interest, which would be really terrific right now. How much money will the account pay after 6 years? So we're going to use our formula. So we're looking for the amount at the end of a time period. So we're looking for A of t. We are starting with an initial amount of $1,000. So that's A. Our rate of growth is 5%, so we'll put that in as a 0.05. And the time period is 6 years, so that's our exponent. So you can combine 1 plus 0.05, gives us 1.05 to the 6th power, and then we would calculate this. To calculate it, you just put it in your calculator exactly as it appears here. You put 1,000 times 1.05, raise it to the 6th power. That should come out to $1,340.10. Make sure you round all your money to 2 decimal places because that's a normal thing to do, dollars and cents. Okay, next example. Suppose we invested $500 into a savings account. This time it pays 3.5% annual interest, and we're going to leave the money for 5 years. So we're, again, trying to calculate a final amount. We're starting with 500. Our rate is 0.35%. As a decimal, you have to move your decimal place 2 spaces to the left. So that would be 0.035. Leaving it for 5 years. So to calculate this, you put 500 times 1.035, raise it to the 5th power, and we get $593.84. This example we're going to have to do in class because it involves using the graphing calculator and a table. So remind me and we'll do that one in class. And again, this is an in-class example. So finally we have this example. The table shows the world population of the Iberian lynx in 2003 and 2004. If the trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? Okay, so first thing we have to do is calculate our rate of decrease. We do know it's decreasing exponentially. So from 2003 to 2004, we lost 30 of these animals. So if it's declining by 30, we're going to take, to find our rate of decrease, we'll take the amount of decrease divided by the original amount. This comes out to 0.2. Since it's decreasing, it's negative. So we want to find the amount of Iberian lynx. If we start with 150, our rate of decline is negative 0.2, and we want to know how many there are in 2014. From 2003 to 2014 is 11 years, so then you can put this in your calculator. 150 times 0.8 to the 11th power. This comes out to 12.88. But since we're talking about a lynx, which is actually a cat, you can't have a partial cat. So we would say that there are approximately 13 of these Iberian lynx left in the year 2014. That's it for this lesson.